Hello, Algebra 1. So we're going to figure out these sequences. So it looks like I'm adding 3 each time here. So that just continues. So that'd be 15, 18, 21, 24. All right, so we need to remember this, and we need to remember this. So this is arithmetic because I'm just adding. So our equation is going to be, uh, say, like f of x, or you can put y equals. Either one of those is going to mean the same thing. Um, The common ratio is 3, so it's going to be 3x. And our very first term, as long as this is 0, will be plus 3. This equation will work, and you can, as you plug it in, plug 0 in, you get 3 out, plug 1 in, you get 6, plug 2 in, 3 times 2 plus 3, 3 times 3 plus 3, 3 times 4 plus 3, etc. Okay, so you can list this either of those locations. That's how it works. This one also appears to be arithmetic. It looks like I'm subtracting 10 each time. So that'd be negative 18, negative 28, negative 38. Okay. So again, I need to remember this. That's the common difference and the 0 term. So I know f of x or y equals, doesn't matter which one you pick. So this is going to go out in front of the x. And then this number here is a positive number, so it goes right there. This is the equation. If I plug 0 in, I get 22 out. Negative 10 times 1, negative 10 plus 22 is 12, so on and so forth. So this will plug in nicely. Oh, that was also arithmetic because we were subtracting. So add or subtract is going to be that. This particular one, it looks like I'm adding 0.9. So I could go, this is going to be 6.8. This one will be 7.7, 6, or 8.6. 9.5, etc. So you're adding 9 each time. So remember this. And remember that this is going to work. So I'm going to go y equals. This is going to go out in front, 0.9x. And then this first term, as long as this is 0, is plus 3.2. There's our equation. Again, this is arithmetic because I'm adding each time or subtracting. Number 4, it looks like I'm adding 7 to both each time. So if you continue this, it would be 13, 20, 27, 34, etc. So again, you want to remember that. This is arithmetic because I'm adding. And I want to remember this. As long as this is 0, this is going to be important. So I'm going to go y equals 7x minus 15. Notice I'm sometimes doing f of x and sometimes I'm doing y equals. Pretty interchangeable at this point, okay? So that was the first page. Now I'll go to page 23 and say, take a look. This looks like I'm multiplying 6 each time. So that'd be 36. And what is that? 16, 18, 196, I believe. Okay. So our equation, I need to remember this. And as long as that's 0, remember that. Okay. So this is geometric because I'm multiplying between each of the f and n terms. Okay, so I'm going to go f of n. Okay, that's the same as that. And I'm going to have 1 over 36 times 6, and 6 is raised to the n power. Okay, if I were to plug in these values for n, it's an exponent. So 6 to the 0 is 1 times 1 over 36, 1 over 36. 6 to the first is 6, 6 times 1 over 36, 1 over 6, so on and so forth. Okay, this one, it looks like, what am I doing to go from, hang on, I gotta look back at my problem. Maybe I wrote down 0, 5, 11, 17. So what's taking place? Looks like I'm adding 6 each time. Do you agree with that? Add 6 there, that gets 23. Add 6 to that, I get to 29. So because I'm adding 6, this is arithmetic. So each term is adding 6. And so if I go with this, then I will remember this. And because that starts at 0, I'll remember that. So I'm going to do f at n, because that matches there, equals 6n minus 1. Minus 1 goes right there. The 6 goes in front. That 6 and n are being multiplied. Number 3, looks like I'm adding 6. Is this the same one? Did I write the same one twice? 0, 5. Oh, shoot. I made a mistake. Let me clear that out. Just rewrite it. I looked at the wrong problem. I wrote the wrong problem down. I'm sorry about that. So 0, 3, 1, 6, 2, 12, 3, 24, 4, we don't know, 5, we don't know. So it looks like I'm multiplying each time by 2. So times 2 each of these, that's then 48, that's then 96. So this is geometric. So the last term times 2, that would go all under our recursive function. So I'm going to go f at n. I have to remember that. And as long as I have that as being a 0 here, this 3 is going to do. So 3 times 2, 2 is raised to the n power. So if I were to plug 0, 1, 2, 3, 4, and 5 in, I'd get the appropriate answers below. This one, it looks like I'm adding, or no, I'm actually subtracting, aren't I? Okay, let's see. 89.7 minus 77.2, it's a 5. So it looks like I'm adding 12.5 to each one. So each one of these add 12.5. So if I add 12.5, I go 39.7 plus 12.5. It's going to give me a 2 carried the 1. That's going to give me a 2 carried the 1. It's 52.2. All right, so I'm going to remember this first term. This is arithmetic because I'm adding. So I'm going to do my equation, f at n. I'm trying to match that, is equal to 12.5, this right here, 12.5 times n, and then plus 89.7. There's our equation. If you have any questions about these, feel free to ask. This looks like I'm multiplying by half or multiplying by 0.5, but half. Oh wait, I take it back. Is it half? Hang on, did I write this down right? Let me take a look at number 5. 2/3. 12, 6, 2. Ooh, you know what? This is half. This is a third. This one can't be done. The sequence didn't work out right. So I just skip it. This one, it looks like if I go term to term, I'm going to be multiplying. Actually, yeah, I'm going to multiply by 3. Is that right? 12 over 15, 12 over 5, 6 over 5, 8 over 5. Oh, wow. You know what? 4. Let me modify this a little bit. If I multiply this by 3 and by 3, that gets 6 over 15. And if I multiply that by 3 and 3, that gives me 18 over 15. Multiply by 3 and 3, that's going to give me a larger number. So what's taking place here? Yeah, okay. This is a tricky one to see because you have to change it to common denominator. I probably wouldn't give you this on a test, but I'm multiplying each time by 3. So I multiply this by 3. That's going to give me 54 over 5. Multiply this by 3. That's going to give me 12, carry the 1, 15, so 162 over 5. That's a tougher one. But remember this and remember this. This is geometric because I'm multiplying. And I'm going to plug in y equals 2 over 15 times 3 raised to the n power. Okay, the 3 has the base, the multiplier has the base. The first term goes in front as multiplied. Looks like I'm adding 8 to each of these. So that's 22, that's 30. So this is arithmetic because I'm adding. Remember that, and as long as that's 0, 10. So we're going to do f at n, because I want to match that, equals 8n minus 10. Just plug those in. The minus 10 goes in back. Keep the sign. And the 8 goes out in front being multiplied. Excuse me. On this one, looks like I'm adding 6. Nope, I'm not adding 6. You know what I'm doing? I'm multiplying by -2. So that'd be positive 32, that'd be -64. So notice it goes back and forth. So in calculus, you'd actually find that's a special case. So I'm going to go f at n. Because I'm multiplying, this is geometric. We're going to take, as long as that's first, that's our first term, so I'm going to plug it in right here. And then I'm going to take -2, and I'm going to raise that to the n power. And that'll work out real nicely for us. Cool. So now I need you to go back into the yellow book and get it to page 35. Page 35. This says, don't break the chain. Okay. So the learning focus, just reading it down, says represent a story in context using tables, graphs, and equations. Use the function notation to write the explicit and recursive equations. Remember, recursive is last plus something or times something. How can I find the pattern of growth in the context? How does the pattern of growth appear in each representation? Okay, so the story problem says, hi, my name is Bill Waits, founder of Super Scooper Ice Cream. I am offering you a gift certificate for our signature Super Sundae, $11.95 value, if you forward this letter to 10 people. When you have finished sending this letter to 10 people, a screen will come up. It will be your Super Sundae gift certificate. Print that screen out and bring it to your local Super Scooper ice cream store. The server will bring you the most wonderful ice cream creation in the world, a Super Sundae with 3 yummy ice cream flavors and 3 toppings. This is a sales promotion to get our name out to the young people around the country. We believe this project can be a success, but only with your help. Thank you for your support. Sincerely, Bill Waits, founder of Super Scooper Ice Cream. So this is a chain email. It relies on one person who receives the email to forward it on. Have you ever wondered how many people might receive the email if the chain remains unbroken? Figure this out. Assume it takes a day for the email to be opened, forwarded, and then received by the next person. On day 1, Bill Waits starts by sending an email out to 8 of his closest friends. Then each of those friends forwarded to 10 people for day 2. We want to know it's day 7. So we're going to call this X, we're going to call this Y. This is day 1, 2, 3, 4, 5, 6, 7. Okay? So on the first day, it said that he is going to send this to 8 people. And then each of those people are going to send it to 10 people. So they send it to 10 people. So that means 80 people will get the next one. Times 10, 800. Keep going. 8,000. 80,000. 800,000. And then 8 million people should get this email about this Super Duper Sundae promotion. That's pretty cool. All right, so our recursive function is going to be the last times 10. So this is definitely geometric because I'm multiplying. Okay, our regular function, our explicit function, is going to be y equals, remember here, that's starting with a 1, isn't it? Okay, so I want to do something with this. Remember, I want that to be a 0. So I'm going to take this 8, though, and I'm going to go 8n, but hang on. Remember, I want this to be a 0. So I'm going to go subtract 1 from that, because if I go 1 minus 1, I get 0. And then, let's see if I'm doing this right. That 8's not going to be there. This here should be a 10. And then this 8 here goes out here. Okay, so take a look at how this function works. If I plug 1 in, I get 1 minus 1, which is 0. 0 times 10 is 0. 0 plus 8 is 8. If I plug in 2, 2 minus 1 is 1. 1 times 10 is 10. And I need to get to 80. So I might have been up to 10. Oh, it's not plus 8. It's... This is geometric, isn't it? Okay. So I have to change this a smidge. Okay. How many people were on the first day? That would be 8. Okay. So then this is going to be raised to an exponent. There's where I made a mistake. So I'm going to use n. So if I used n right now, I would get to 80. So I'm going to have to make it n minus 1. So think about how this is going to work. Plug in the 1. 1 minus 1 is 0. 10 to the 0 is 1. 1 times 8 is 8. Cool. Let's try 2. See if that's going to work. 2 minus 1 is 1. 10 raised to the first power is 10. 10 times 8 is 80. And if I plug 3 in, it'll give me 800, 4, and it'll give me 8,000, and so on and so forth. Okay. Morning. So, growth of geometric. You're going to have the common ratio. This base will always be bigger than or greater than 1 at some point. Okay, if it's growing. Okay, if it's decreasing, it's going to be a fraction. Fraction that's between 0 and 1. Okay, I'm on page 36, so we just did our discussion a little bit. It says, although offers like Bill's are usually scams, let's think about what would happen if he really did give away all the ice cream in the emails. If Bill gives away a super sundae that costs $4.95 to every person who receives the email during the first week, how much will he spend? Wow. So you have 8 and $4.95 plus 80 times $4.95 plus 800 times $4.95 plus 8,000 plus $4.95, and that keeps going. 80,000. So this is going to be a lot of money. In fact, I think our ice cream shop might go out of business if everyone was one of those coupons. 8 million coupons. Think about that. 8 million times $4.95 is a huge number. It's like above $32 million. That's a lot. Okay, so think about the geometric sequence. You make the table, you create the explicit equation, the recursive equation, and then you could graph it, and we don't have a graph here that we're using. So lesson summary, this is the bottom of page 36. In this lesson, we modeled a real-world situation with a table, graph, and equations, both explicit and recursive. We didn't really graph it, but we could have graphed it. But I mean, 2,80 is a wacky doodle point. 3,800 is way off your paper. We learned to use mathematical notation when writing recursive equations for geometric sequences, and how to identify the common ratio in each of the representations of the geometric sequence. Okay, so for tonight, I would like you to work on page 37. This is in the yellow. And it's just the front page. That's all you have to work on. That's all we have. If you have any questions, ask me or watch the lesson I'm doing as well. Have a nice day.